Looks like it's leveled out. I'll get started. Thanks for joining us again today for the intersection of SUE, ASCE, and PointMan. Insights from industry leader Jim Anspach. Presented by ProStar, the world leader in the development of precision mapping solutions. My name is Garrett Kohler, and I'll be your moderator for today's presentation. Jim will be joining us, obviously. He's an affiliate professor at Iowa State University and chair member of the Technical Advisory Board for ProStar, as well as Randall Harper, ProStar Solutions Specialist. Jim, if you could introduce yourself and provide a little bit more information, that'd be awesome.
Sure. Hi, Jim Anspach here. I was the chair of ASCE 3802 and 3822. Now I'm no longer chair, so I'm going to have some fun on the next edition and not worry about the details. But I have been working on large infrastructure projects and managing the utility portion of that, whether it's the investigation or the coordination for more than 40 years.
Awesome. Well, we appreciate you being here. Randall, if you want to introduce yourself a little bit more.
Yes, sir. So like I said, I'm Randall Harper, Solution Specialist for ProStar. I have a background in GIS and CAD. Basically, I started at Apple and worked my way from there into the utility industry, doing as-builts and various mapping tasks and other things of that nature before I ended up at ProStar. So I have experience in multiple industries, and I hope that I can be of some help today.
Awesome. Well, thank you both for being here. We'll get started. Randall, it's all you.
All right. Well, thank you for the introductions. So our focus is to serve the critical infrastructure industry. That includes construction, DOTs, oil and gas, engineering and survey, locating municipalities, one-call centers, and utilities. So infrastructure has two sides to it. Most people just think of freeways and the surface, but for every freeway and road that you build, there's going to be miles and miles of underground infrastructure that are directly underneath or next to it. So there are 2.5 million miles of paved roads that we rely on. But on the other hand, there are 35 million miles of underground pipelines and utilities that we rely on even more. And this is for drinking water, heat, waste removal, and other things like that. And these infrastructures are interconnected. You can't work on the surface without impacting the below ground and vice versa. So here's just some statistics on damages. 500,000 represents the number of strikes per year in 2019, or I should say 2020, as that report was from 2019. $10 billion is the annual estimate to locate underground infrastructure before construction, and $30 billion is the annual impact of underground damage on the economy. And that can range from everything to a burst water pipe, to fiber being shut down and shutting down businesses, to fires and gas and explosions, and even loss of life. Now, this is a cost saving study that was conducted with basically one project was using PointMan and one project was not using PointMan. They're of equal scope and value in the same city, and they were both 10 miles of highway over 3 years. Project 1 had 130 crew members, and Project 2 had 100 crew members. Project 1 had 3 line strikes. Project 2 had 147 line strikes. Can you guess which one was using PointMan? Well, that would be Project 1. But what does that mean in dollars? The problem is utilities and pipelines are mapped using paper maps called as-builts, a form of design drawings that are how the utility or pipeline is initially planned to be installed in the ground. So that's the legacy way of doing things, using paper and just hand drawing everything based off like 35 feet west of the curb, or based off some survey marker that was been on the ground for the last 100 years. Now, current practices include using electromagnetic locate devices and a spray paint can to approximate the location of where a utility is buried. The current methods do not provide precise locations or any supporting data, and stakeholders that take on liability do not trust these markings. Now, what this means is you have people EM locating, painting the ground, and then coming in and then resurveying and re-EM locating because they don't trust those paint marks that they see. So they're doing double work because they don't believe what they're seeing with their eyes. Then this is only getting worse every year because every year we are installing more and more underground, including 300,000 miles of fiber optic that goes into the ground every year in the United States. And that's not including the fact that we have to replace pipes for water, for sewage, for gas, just over time, and just do a bunch of maintenance on the infrastructure in general. So this is the current data management and workflow process. Locate utilities, survey paint marks, upload the data, review the data, import into your CAD or GIS, where you process it, and then you send it back out to team members. And the solution is PointMan. A few key things to know about PointMan. It provides the ability to capture, record, and display the precise location of critical infrastructure both above and below ground, including buried utilities and pipelines. So what this means, just based on the image here, is you're digitizing everything by capturing it with your mobile device that's hooked up to your GNSS receiver and your electromagnetic locator. So all of this, instead of having to transcribe it on paper, is immediately digitized and turned into what is essentially a digital as-built, because it also contains the metadata associated to those features that you captured. How does PointMan work? Well, you take your locate device, pair it via Bluetooth to your mobile, and your GNSS, pair it via mobile, and both of them will sync up to the cloud after you capture things in the mobile device. It's that simple. So this is just an example. You can see this is an example of like an as-built line that was on the right-hand side, and it was collected on the left-hand side with the radio detection and a Trimble DA2. And you can see the line is just on the other side of where the as-built said it was, and it's off by 100 feet. And I'm sure that we've all been there. And that is a pretty common problem with as it relates to old as-built practices and locating, modern locating. But here you can see that what you see on the mobile is also visible on the cloud as well. So you can view it from your trailer or your office, the exact same thing that your guys in the field are seeing. So here's the PointMan workflow. Capture field data, process it in the cloud, and it's made readily available to team members. We can capture precise test hole data with PointMan. You can include images and as attachments, and you have the metadata associated with all this data as well. So you can see this selected point here in blue is has the metadata on the left-hand side and then the image on the right. So you can cycle between those and basically see what the guys in the field were seeing. You can recall and visualize data. So in this case, this is kind of just what it looks like to the guy in the field. But if you look at the tablet to the left, you can see that what he's seeing is actually how to get to that green point. Some of our industry partners, we like to be agnostic. So we partner with pretty much every major manufacturer of GNSS and EM locators out there, including Trimble, Battle, and radio detection, and recently the 3M Dynatel. Some government regulations. Digital records are becoming more relevant in this modern age. In fact, state governments are beginning to see this and have begun rolling out new regulations. One of them is the California Code 4216.3-5. Starting this January 1st, all new subsurface installations shall be mapped using a GIS system and maintained as permanent records of the operator. The CDOT mandate, the use of PointMan to capture digital records, is mandated during all new installs in Colorado DOT right-of-ways. And I'm going to hand it off to Jim now.
Okay, stop sharing your screen. There you go. All
Now, I
right.
encourage you all to ask questions in the Q&A. We'll get to those at the very end and hopefully answer those questions for you.
All right, so I'm going to talk a little bit about what subsurface utility engineering is. There's been a lot of definitions over the years. We change them up all the time. They're in the process of being changed again. People make up their own definitions. Some are pretty good, some are pretty poor. So I'm not going to talk about a definition, but I'm going to tell you what we're trying to accomplish with subsurface utility engineering. To reality as we can get with the pre-existing conditions. Let's face it, that's why we do a topo survey and spend all that effort to get it on a set of plans. We're in a digital file nowadays, accurate to within millimeters, if we can get it. But in the past, we didn't pay very much attention to that portion of the underground that we can't see, where we can't guarantee what we can't see underground. So subsurface utility engineering's ultimate goal is to provide sufficient, reliable data to reduce and sometimes even eliminate cost and schedule issues on a project that are due to the existing known, misrecorded, and unknown utilities. So it's all about taking different sources of information, whether it's from a pipe and cable locator, whether it's from a permit, whether it's from an old set of plans, whether it's from what you can visually see that, yes, there's a fire hydrant there. I can measure that, whether it's from an excavation, wherever that data comes from, we meld that together and use that to come up with the best idea that we are the most certain about of where the utilities are on a project. And then we communicate that data to the different stakeholders that may need it, the designers, the planners, the builders, the utility owners, the one-call locators, and so on. So we developed a standard to help us in this effort. ASCE 38, standard guideline for investigating and documenting existing utilities. You know, these utilities are buried out of sites, and geophysics can't find everything. Let's use a medical analogy. You know, you go to the doctor and you have a sore stomach. They might have to do an X-ray. They might have to do an ultrasound. They may have to do an MRI. They may do a CAT scan. They may do a PET scan. Heck, they may cut you open. But all of those geophysical methods work with different materials and see different things. And utilities are made up of all kinds of different materials in different environments. So we need a wide range of that. And so ASCE 38 really came about as a way to portray on a set of plans what the uncertainty of the utility that you are showing as far as its location is. So if you have a high quality level, A or B, it's a lot more certain. You're saying, I'm more certain where this is. It's not a guarantee where it is. You can't even put an accuracy to it because you can't measure anything. You are interpreting some geophysics and you're trying to figure out what are those geophysics trying to tell me. So ASCE 38 came about when in 1994, there was pressure from various companies that were doing subsurface utility engineering back then to create an association. And the association, the goals of that stated association were going to be to further the interests of the members of the association. Well, the members of the association wanted to dumb everything down. They didn't like the fact that engineers had to be involved. All they wanted to do was dig holes with a vacuum truck. And that's not what we wanted. And I happened to be teaching a class at University of Alabama with Dr. Dan Turner. And Dan Turner was the incoming president of ASCE. And he said, look, you don't need an association. You've got the largest club of engineers in the world with ASCE. Why don't you take what you're doing and create a standard, put it in the standard, and ASCE, this large club of engineers and surveyors, will stand behind it. So really, that is how we started down the road with ASCE 38. So it's both a prescriptive and a performance standard. What that means is it's you are saying this is quality level C, there are certain actions you must try to do and achieve to call it quality level C. So it's prescriptive in that manner. As a performance standard, it says this is the professional judgment, the engineering judgment that needs to be used to determine when I'm going to do the investigation, how I'm going to iterate it, when I'm going to sequence it, where I need it, and what kind, and what the scope of that investigation is. And then, of course, the ascribing of a utility quality level on that. So ASCE 38 is for subsurface utility engineering. However, there is this thing called one call locating. It's not the same. What we are trying to do is put stamped, reliable information on a set of plans, not on the ground. So our goal is to provide and communicate that reliable, qualified utility data to stakeholders so that we can reduce or minimize utility issues. Because really, what we want to do is avoid utility relocations and problems through good planning and design if we can. If we can't avoid it, maybe we can minimize it. If we can't minimize it, maybe we can accommodate that utility in place by getting a policy exemption or going back to the federal government and saying, we're going to leave this in place because we can't use the Buy America clause. There are no pumps of this kind in the US without taking 3 or 4 years of lead time. And, at the end of the day, we might have to relocate something, but where are you going to relocate it to? It's pretty busy down there. So it's not just a matter of saying this utility is in conflict with our design. You also have to figure out where you can put it so it's not in conflict with anything else. And have the right of way to do it. So all of that takes time and effort, and that's what we're trying to accomplish. But we have a new standard, ASCE 75, that is also in play. And this started about the same time as 38. In 1994, the National Transportation Safety Board had a summit where several of us were speaking at. And from that summit, there was a recommendation that we do need better records. What we call as-built are not as-built. They're as planned or as designed, and there is no definition of an as-built or a legal requirement or a standard out there. So the NTSB said somebody needs to do it. Well, quite frankly, in 1994, that cry went out, but nothing happened. However, in Canada, they were looking at developing their own ASCE 38 and started looking at it and adding in elements of of how can we make better records, and decided, no, we'll just reference ASCE 38, but we'll come up with a standard on how to use, how to make a better utility record that's more accurate. And they called that CSA S250, and that was published in 2011. Well, finally, in 2011, we looked at that here in the U.S. and said, you know, we need to get off dead level here in the U.S. and do something about this. So in 2013, ASCE put up a new standards committee. 10 years of development later led to ASCE 7522. So what this standard says is that there are accuracy levels if you can measure a utility and survey it as it is going in. So for newly installed infrastructure, we can say it is accurate to plus or minus X number of feet or inches with this level of deviation. You can't do it once it's covered up. So this is for newly installed utilities, but we wanted to not only make a paper-based utility record better, we wanted to figure out how we can do this in a digital manner and how we can share the information then to stakeholders that need it. So AS 72 is really for utilities that you can see because they are exposed in some fashion, and either above ground or below ground. So what we really have in there is the minimal attributes and the 3D geometry that need to be captured for utilities. And it's a digital standard, so we can use it directly with BIM and virtual design and construction. It's fully compatible with everyday Count 6 initiatives out there. So what I want to talk about specifically is how PointMan allows more efficiency to the subsurface utility engineering provider. I'm not really going to talk about how it benefits one call or how it benefits utility owners or anything else. I'm going to focus on that aspect of how does it benefit the designers in the room. Well, time is money. And if we can reduce the amount of time it takes us to do an investigation with the same or better quality, we've probably saved the project money. In addition to that, if you have good data, you can turn that data into information. And if it's actionable, we can make decisions about it. And it really ends up being project wisdom with some business outcomes. So I'm going to talk a little bit about how we can save time and hence money with PointMan. So you saw this slide before, the traditional practices. We put a mark on the ground, we survey that mark, we send it to the CAD operator. CAD operator downloads it, puts it into a CAD platform of some kind, MicroStation, AutoCAD, whatever it might be. And then that is used for design. But one of the things that we had to always do was, sitting in the office, we had to figure out, is the mark on the ground right? Do you trust the person using that? Was the equipment calibrated today, or is it off a little bit? Was the person paying attention? And without some mechanism to check that, other than running back out into the field and doing point checks on somebody sufficiently, and then checking to make sure what was in fact put on the ground ended up being surveyed, and check to see if that ended up in the CAD file correctly. All of that was a lot of necessary quality assurance steps that you had to take. But what we're able to do is look at this data in real time in the office while it's being collected, or the next day. pretty soon, and we can look at it and say, oh, look at all of this data that's being collected from this pipe and cable locator. I've got the positioning aspect of it when it's got a GPS attached to it. It's giving me this signal strength. It's giving me this current direction. It's giving me this depth. It's giving me, I'm using this particular frequency. All of these attributes and metadata is available for each point that I collect in the office. And I can use that to look for trends and say, hey, this doesn't look right on the plans. Let me delve into the data. And so you can delve into the data and you can say, yeah, the data doesn't align. The signal strength really dropped off here, and it doesn't look right. So now you're targeting your additional field work. And I can tell you from using this system that it reduces about 50% of the field checking that needs to happen on pipe and cable locators. So there's some real time that is out there. And it also allows you to identify, the problem employees. Maybe they're a problem all the time, but maybe they're just a problem that day. Maybe they're not feeling well. Maybe they've got something else on their mind, but you can check their data in the office. One of the other time savings is, about 60% or so of the utilities on a project might be capable of being found or imaged or detected with a pipe and cable locator. The other 40% can't, but if 60% can, one of the things you must do is have a field sketch so that you make certain that whatever in fact was designated in the field ended up on the plans. And so a field sketch is part of that quality assurance. It just has to happen. But the old ways of doing field sketch, when I was in the field with colored pencils and big sheets of paper, well, that's kind of been replaced with tablets and CAD or Adobe programs that you can sketch it on. But it's still a real time intensive labor. And if we can use PointMan to help create the field sketch for 60% of what it is out there, we only have to add in an additional 40% with traditional means. So there's a big time savings. We also are looking at the accuracy and doing the survey within the accuracy spec simultaneously with the designating. So we use our equipment, we say, yeah, that's a good mark, push the button, bang, it's already surveyed for us within tolerances, which is 0.2 feet horizontally for ASCE 38. So the mark on the ground is surveyed to within 0.2 feet. Doesn't mean the mark on the ground is anywhere near where that utility asset really is, because that's a different function. That's a geophysics function. But you add all this together. So if you can get a 30% time saver on top of a 40% time saver, that's some real money. And then you can also use that real-time visualization, both in the office and in the field, as you saw, in the cloud and on the tablet or phone, to see where you stand. This was surveyed rather than have a different crew out there. You can also then add in those geophysics that aren't compatible yet with PointMan, such as GPR, time domain electromagnetics, maybe a pipe and cable locator that doesn't have streaming capabilities, maybe a magnetic Schoenstatt, magnetic magnetometer. All of these kinds, and in a really complicated area where the utilities are crossing over each other and they're braided, it's really difficult to make sure that your field sketch is showing that correct geometry. So this real-time visualization is pretty nifty for that. So you can overlay also the existing record information. So before you even go out there, you can add in record information, and maybe it gives the designator in the field a little bit of a guideline as to what to look for. You know, there's two schools of thought on that. Don't furnish that information and they won't be biased, or furnish that information to help them not make an omission. So it's 6 of one, half of a dozen of the other, but having it available at your beck and call, I think is a good thing. It's just a matter of how much you trust it and when you use it and who you allow to see that data. Another thing is, as we are beginning to add depths to our data in the field so that we can bring it back and create a 3D model. It used to be that you'd have to put a mark on the ground, put a shot number on that mark, and either write in a notebook or write on the ground what the depth is, and the surveyor would come behind it, pick that up, annotate that depth in the field book, and it would end up to the CAD operator, and they'd have to do it. Lots of opportunity for transposition of numbers or mistakes. You know, another thing I've seen is people just writing a depth on the field sketch. Well, you don't really know where that was. Was it in front of this house or the other house? So it's a time-consuming effort and a loss of quality to track this depth on by paper or multiple touches of that depth information. But what we're able to do with PointMan is automatically, at least for the pipe and cable locator, get that depth. And we know that it's a pipe and cable locator. So when we build that 3D model, we know that the depth is originating from the middle of that electromagnetic field, the middle of where it is originating from. So the middle of the pipe, which is important. If we had a depth from a GPR, for instance, it would be the top of the pipe. If we had a depth from a sonde in a big empty storm drain that we needed that was on a curve, it would be on the bottom of the pipe. So by this method, not only do we annotate a depth, but we can say this is the instrument that got us the depth, or the procedure that got us the depth, so that we can know when we're building the 3D model how to center the size of that structure in there. So another advantage there. Creating these you write a note and you'd put it in the file saying, I'm having trouble in this area. I need my supervisor tomorrow or the next day to do this work because I can't do it. Or this instrument isn't working. I need somebody to come out with GPR. And if you don't write a field note, somebody's going to forget about it. It doesn't get done. So you have this field note, but on the field note, you have to say exactly where it is you're having this particular issue. With PointMan, you're able to create a point and attach a field note to that point. The same with a photo. So you're able to again be a lot more efficient with a higher quality with the concept of attaching at a particular area a form, a photo, a point, a field note, that kind of thing. Here's an example of some pictures we might want to put in that file, because it all helps, especially in that end goal of subsurface utility engineering, which is not just a map. It is in fact the basis of information for utility coordination and project design to move forward. So it's a lot more than a map when you're out there investigating it. Now here's another advantage, which is a little bit more esoteric, but it happens all the time. On the left, that is a typical one call mark for an intersection. It's pretty busy, pretty messy. Looks like a pile of crap out there in the street, right? And on the right is what one particular Sioux firm has said, you know, this is what my paint marks look like. Look how much neater that is. Well, that's a pile of crap too, because you're not marking for damage prevention. You are marking for just the information needed to pick it up, to get it on a set of plans and know that you picked it all up. So you don't need these big long marks out there. And these big long marks in these color codes are disturbing to the utility owners, who are in fact trying to go back later and mark for damage prevention, and the marks may be different from what they are doing, or a different color or a different format, and it may be confusing to the excavator, and that creates liability, and it will and does draw the sue firm into lawsuits down the road when there's a damage. So, you know, it used to be, okay, we're surveying this, you know, in a separate operation, but we're going to leave our marks very short and sweet, only big enough for us to know what it is we are surveying, and then go back and do some quality assurance checks. But now on the right, maybe you don't need marks that are even that neat and small. Maybe you can just put a point. Maybe it's just a keel mark on the ground. So it's a real advantage in a what I'm going to call a purposeful marking. We do a lot of test holes to actually prove what our geophysics are trying to tell us, or get information on size of or material of a particular utility structure. And it used to be we'd have to dig it, expose the utility, we'd create a sketch, we'd do some measurements, we'd repair it, we'd have to go back out and survey the surface, we'd have to transfer that data to CAD, we'd have to do some QA, and then it would be finally given to the engineer to seal. And so he's got to assemble all of that. But you could do it all in one step. You know, dig it, collect the data, survey it, patch it, look at it in the field in real time before you patch it, so you don't have to dig it back up if there's any question, attach a photo, and you're done. And the engineer has a way to monitor that in real time. Again, reduces field survey time, perhaps remobilization, questions that happen, all of that. We can also customize these data dictionaries and say, okay, for this, I want the line to be drawn in red when it comes in from the field from PointMan, and this is the size I want. So, and it's in casing. So you can do all of these kinds of fields that are scalable, that meet not only ASCE 38 but ASCE 75. You know, here's another example of the different kinds of dictionaries you can set up, either by state DOT or by job or by contract or by utility owner. You really have a pretty broad capability to do that. So one of the things that ASCE 38 and 75 say is, you know, part of that job is survey. And with the PointMan system, you get what we call precision and pedigree. So we know what the accuracy is. We know how many satellites were out there. We know what the geoid corrected elevations were. We have precision measurements. We know what kind of receiver was used, and we can correct that receiver on the fly. Another big advantage is we can then use this and ship it directly from PointMan into Open Roads Designer or some other shapefile, and start the process of creating that 3D model. Now, the final deliverable of ASCE 38 is a stamped drawing that shows each particular utility segment at its achieved utility quality level. Without a stamp by a licensed professional engineer, or in a couple states surveyor, you can't have a quality level, because the quality level is that end result that all the information was collected and processed under the responsible charge of a professional licensed in that state to protect the public health, safety, and welfare. So PointMan provides ancillary data to help that PE make an informed quality level judgment by being able to look at signal strength and some of that data coming in and the survey quality. They could look at it in other ways, but it would be more time consuming and therefore more expensive, and the project may not stay on schedule. It also brings all that data into one centralized location for processing, which is a lot more efficient. So, here's a little bit in Colorado what that final deliverable would look like. There's an engineer's seal. Every utility segment or structure in there has either a quality level or an accuracy level. You're able to go back and look at how that data got to that point. It's pretty nifty. So with that's kind of the advantages I see with using PointMan to assist the subsurface utility engineer in doing their job perhaps more efficiently. So with that, I wanted to leave some time for questions and maybe some answers if we have them.
Well, perfect, Jim.
Oh, sorry.
No, go ahead, Randall.
Go for it.
Okay, so one of the questions, I'm excited to see you have a DOT behind your vision to help develop your system. In a perfect world, if you were to secure partnerships to get nationwide agreement in using PointMan, how would you deal with the datum survey protection components? Going area to area, would the PointMan software keep the coordinates in a consistent format or perform conversions for the subscriber? Do you think that would affect precision?
Well, I'm not a surveyor, so I don't have an answer for that, but I do know that we have been using this in multiple states for multiple clients with multiple different kinds of survey types and systems. And I can say that it takes a little bit of setup each time you go someplace new. But it does end up getting set up properly, and once it's all synced up and checked, it seems to go pretty well. So I would defer the true answer of that to a licensed surveyor who has been or engineer surveyor who has been doing this in multiple states. But I do know it is being used in multiple states. And it seems to work in each one, regardless of the base mapping or the base survey components that you're trying to tie to.
And I just want to add that we natively collect in WGS84, but are able to export that into other coordinate systems and projections. So the base projection, the base collection is always done in WGS84, regardless of where you are. So that would, I think, keep things at least pretty consistent overall, and you would just be exporting based on your local state plane or site calibration or something like that.
Awesome. So another question specifically for Jim. This one's going to be, if you believe eventually one call can be convinced to move away from paper, do you have strategies on how they could authenticate what abandoned lines could be removed from the GIS?
Yeah, great question. In my experience, up to 40% of the utilities that I find, at least in an urban or suburban area, is abandoned. And the real question is, how do you know it's abandoned? You can expose it even and look at it and call the utility owners that are in the area out and say, okay, here's a line, whose is it? And nobody raises their hand, and somebody says, well, it must be abandoned. It's nobody's live line. And then somebody goes in and cuts it, and there's a disaster created. So authenticating abandoned lines is one of those areas where I think there's going to need to be better a condition assessment or remote sensing capabilities developed so that we can look at a utility when it's exposed, perhaps, and make that judgment from either some sort of geophysics, or you have to track the entire system out and say, look at this, it ends at 200 feet away from here. Let's expose where it ended and see why it ended. Oh, there's a big hole in the pipe here. That means it's probably abandoned. Even abandoned facilities, though, are used in some cases by other utility owners who purchase those assets. So, for instance, one of the big original fiber companies purchased the entire Western Union telegraph system and used their abandoned conduits to put new fiber optic in. So we have to be very careful in labeling some abandoned. And I don't have a good answer for that, Randall, because it is a very difficult question. And I think the best answer, at least at the moment, is we need to show all the utilities that we can find, including abandoned ones, on the plan, and not assume that they're abandoned unless we have evidence to the contrary.
Thank you, Jim.
Sure.
So this is from Jeremy McDonald. I've had a question come up a couple times this season about utility as-built on DOT construction projects. Some of our contractors, construction surveyors are asking if they need to collect the as-built data in TMOS or in PointMan. A couple of the surveyors using Trimble R12 and Trimble data collectors have as-built installations, but most of the attributes are either lost or missing in Transparent Earth / PointMan. What is the best way to capture all attributes like conduit material type, fiber strand count, quality level, invert elevations, and so on?
Jeremy, I don't have an answer for that other than I would say, from what I know, those attributes should be available in PointMan with those Trimble data collectors.
So I can probably add to that. We have a very configurable data dictionary. So it's just a matter of setting it up to, and this is gonna kind of piggyback on another question related to this, but the user can actually set up the data dictionary to basically be as thorough and as detailed as you need it to be. So you can add strand count, you can add quality level and all of those things in there. I believe TMOS is based off the CAD system for CDOT itself. So it can have things added to it, but I believe according to their CAD standards, they aren't necessarily using all of that data. And this is someone asked, would PointMan ever consider putting out a standardized recommended data dictionary? Seems like Jim would be a great guy to help with that, which I agree, Taylor. That's something we are working on. We believe that it's important for everyone to have a basic dictionary to work off of. So we are constantly working on implementing new ways to enhance that dictionary. So you can look forward to a future dictionary that is more, let's say, survey oriented. It's just a work in progress right now because we don't want to put something out there that isn't quality.
We have an ASCE research project going right now that addresses that a little bit, in that, every client has their own survey standards, their own CAD standards, their own GIS standards, their own depiction standards. Many of them conflict internally. They certainly conflict with each other. And there is no standardization out there. I mean, you can go to a Trimble data collector, you can go to Eagle Point, you can go to, whoever, they're all different. And we are trying to, with ASCE 75, at least say, at least as far as utilities go, this is the attribute data we want collected for it. So we're trying to do that through ASCE 75, trying to get all the different clients throughout the country on one sheet of music is proving impossible. And it probably won't ever happen unless there's a federal law that says you must.
Thanks, Jim. Another question. What are your thoughts for as-builts of pipelines using the MFL, in quote, smart pig method?
Yeah, so that's that inertial system of surveying a pig accurately before it goes in a utility, and surveying the pig where it comes out accurately, and looking and making sure there's no drift in the survey data in between, with proper procedures. I think it's a great way to create a 3D digital model of a utility, and it is compliant in my mind with both ASCE 38 and 75 if the procedures are done well and the data supports the results.
Great. So for the field notes or test holes, the data collected, can it be exported to a PDF?
I can answer this one. So when we have a PDF, those field notes, you can actually fill out a digital form, which can be emailed or exported as a PDF. We can also export all the data in the form of shapefiles, GeoJSONs, and CSVs. So there's multiple ways to get the data out of the system.
Great. Another statement in question. I heard a bit about the quality levels needing a stamp. We often don't stamp preliminary sets such as 30, 60, 90% process sets, but we are in the middle of the SUE process too. Therefore, we show the quality levels that are being developed once designated. Are you saying we should level off the QL line types until it's stamped?
That's a really great question, because it is a debatable and not well practiced or understood aspect of ASCE 38. What ASCE 38 says is that a line segment, each line segment has a quality level on it, and in order to have a quality level, it has to have a stamp. However, we do have preliminary progress sets, and maybe, to some degree, it's a little bit of a misunderstanding of the quality level that has caused this. You might think that quality level D, for instance, is record information, and you go and get the record information, and once an engineer looks at that and says, yeah, this record's correct, or I'm going to change this record and I'm going to put it on the plans, that they can stamp that at quality level D, and that is true, they can. But another aspect of quality level D is I wanted to get quality level B, but I couldn't. The geophysics didn't work. So what am I going to do? In fact, that's really where quality levels originated from. We wanted everything, if possible, to be at quality level B. And then if it couldn't be at B, we had to say, well, what is it? Well, it's from records, or it's from combination of records and sufficient data points where we can get a good location, like at a fire hydrant or a topo feature. All that's well and good. So a lot of SUE providers are in fact performing their work in phases, and you have to be careful of what it is you're sealing and what the phase is. And you have to realize that if you stamp something and it's preliminary, you may have to go back and change it. You can't just leave it there. if you go back and make a change at some future point. So there's a lot of debate over whether any plans from the utility investigation stage should be stamped until the engineer who's stamping it says, I'm finished, or not. And so I don't have a good answer for that. It's certainly something that needs to be further discussed and debated on how we want to handle that. I'd love your, your feedback, because it's obviously you've been thinking about this, Scott, and it is a point that comes up from time to time is, should I stamp it or shouldn't I stamp it? My point of view is once it is issued for construction, it needs a stamp. Prior to that, maybe you can get by without a stamp because you're not using it yet for the ultimate goal of getting something built.
Perfect. And I've put my email into the chat. So if you guys have any questions or have any kind of concerns or anything like that, just send us a chat and email. I've also put Randall's in there as well. You need a little bit of technical advisement. Looks like there's no other questions already. So if anybody has anything else to add, just let me know, but we'll end it at this. So, well, a lot of great insight today and some good knowledge on PointMan and the industry itself. Jim, I appreciate you being here. Randall, you as well. Everyone else for being here as well. Thank you so much, and we'll see you next time.